Hello student, I am Nirmala Morade, Assistant Professor, Department of Mathematics from S.V.K.T College, Devali Camp, Nasik. In last lecture, we studied arithmetic mean and related examples. So we know that arithmetic mean is one of the measure of central tendency. So for a series, suppose we consider the observations are x1, x2, xn. Then the arithmetic mean is the sum of all observations upon total number of observations. So here number of observations are small n. So sum of all observations, that is x1 plus x2 plus x3 up to xn divided by n, is the arithmetic mean of the given series. So if data is given in terms of ungrouped frequency distribution, so we have to given the observations x1, x2 up to xn, and the corresponding frequencies are f1, f2, fn. So in this case, we calculate the product xi, fi, I is from 1 to n. Then the arithmetic mean equals to summation of fi xi divided by summation of fi I is running from 1 to n. And also we studied the third case, if the data is given in terms of group frequency distribution. That is, we have to given class intervals, we have to given the corresponding frequencies. So in this case, first we have to calculate the mid value of each class by using upper boundary plus lower boundary upon 2. By using this formula, first calculate the mid value of each class and then consider these mid values as x1, x2, xn, and take the corresponding frequencies. Calculate the product x1, xi, yi from 1 to I is from 1 to n, and then use same formula. Arithmetic mean is same as summation of fi xi upon summation of f. Also we studied the arithmetic mean or simply mean for the two groups. So combine arithmetic mean, suppose we have to provided the two groups, first group with n1 number of observations and the corresponding mean is x1 bar, and for second group number of observations is n2 and the arithmetic mean is x2 bar. Then if we combine these two groups together, we take these groups together, then the arithmetic mean of this combined group is given by x1 bar into n1 plus x2 bar into n2 upon n1 plus n2. So if the classes are open-end classes, that is one of the limit is not specified, in that case it is not able to find the arithmetic mean. So in that case we consider the mode and median as a measure of central tendency. So in today's lecture we are going to study mean, what is mean by mean, different formulas in different cases, that is mean in case of simply series for discrete data, also median in case of group as well as the ungrouped frequency distribution, and we are also consider all types of the examples. So these are the learning objective of our today's lecture. After watching this video, students are able to understand the concept of median, what is meant by median, what are the different formulas of the median for different type of data, also able to solve the examples of the median. So now first we see the general definition of median. What is meant by median? So median is one type of average. Median is one type of average. Actually it is known as the middlemost observation. roughly speaking, median is the middlemost observation if the values of the variable are arranged either in ascending or descending order. Ascending means smallest to largest. We have to write the observations or values smallest to largest from left to right. So consider one simplest example. Suppose we have to give these observations, and now first thing is we have to write all these observations in ascending order or descending order. Now I have written here all the observations in ascending order, that is from smallest value to largest value. So here first smallest observation is 1, then 2, then 3, then 4 and continue. Write all these observations in this form. So if you just cut the numbers, one from left side and one from right side. Suppose I cut first 1, then 9 here, then 2, then 8, then 3, then 7, then 4, 6. Here the middlemost observation is remaining, which is 5. So this is the median of the given series or given numbers. So here 5 is the middlemost observation and it is the median of the given data. So let us consider another example. So here we consider the observations, some observations. Again we apply the same step here. We consider or we write the all observations either in ascending or descending order and then find the middlemost observation. So here in first case the middlemost observation is only 1 and that's why that is the median of the given data or given series. But in this case the middlemost observations are 2. So what we can do here? So in this case if there are 2 middlemost observations, we take the average of these 2. So in this case the median equals to the average of middlemost observation, that is 5 plus 6 upon 2, which is same as 5.5. So if you observe carefully, in previous example the number of observations is odd, but in this case the number of observations is even. So depending on how many observations are given, we can generalize the formula for the median. So let us see what is the definition of median. So suppose we have to given a series or set of values of a variable which is arranged in either increasing or decreasing order, not increasing or decreasing, we say here ascending or descending order of a magnitude. Then the middlemost observation is called as the median of that variables or median of the series. So if you observe carefully, due to the median, the series is divided into 2 equal parts. The first half part contains the values or variables less than equal median and the next half part contains the value greater than the median or sometimes may be equal. So median is nothing but the one type of the positional average, because median is defined as the middlemost observation. So now before going to the general formula for the median, let us see what is meant by even and odd number. So all of you know that if we consider the numbers -4, -2, 0, 2, 4 and so on, these numbers are known as the even integers. So any integer which can be written in the form of 2k, where k is an integer, that is k is 0, plus minus 1, plus minus 2, then the corresponding integer is said to be even integer, otherwise it is said to be odd integer. So any odd integer can be written in the form 2k plus 1. Sorry, there is one mistake, so here you should write 2k plus 1. Odd integer, the integer which can be written in the form of 2k plus 1, where k is from 0 or k is either 0, plus minus 1, plus minus 2 and so on. So if we put k equals to 0, then we get 2 into 0 plus 1. So 1 is the odd integer. Similarly, you can find the other integer minus 5, minus 3, minus 1, 1, 3, 5. All these are the odd integers. So remember, any integer which is a multiple of 2 is called integral multiple of 2 is called the even integer, otherwise it is called the odd integer. So let us generalize the formula for the median for simple series. That is, simply we have to given the values of the variable. Suppose we have to given the n values of the variable, and then we have to arrange these values either in ascending or descending order of magnitudes, and then if n is odd, so we know that if n is an integer, either it is odd or even, but not both. So if n is odd, then in that case the median is the middlemost observation, which is only one observation. So the median is defined as n plus 1 upon 2th observation, or n plus 1 upon 2th value of the observation if n is odd. And for if n is even, so if n is even, in that case there are two middlemost observation, and that is why we consider the average of that two middlemost observation. And so in that case we calculate median by using this formula. So we calculate the average of n by 2th value plus and its next value. So there are two middlemost observation, and that is why median in case n is even is given by this formula. Median equals to n by 2th value plus n by 2 plus 1th value. Okay, so these two formula are useful for the simple series. Now let us consider some examples using these formulas. So we consider the simple series. Now take the first example. So we consider some smallest number of observations here. The question is find the median of the given observations. So now first thing is we should arrange this data, we should arrange these observations either ascending or descending order, that is smallest to largest or largest to smallest. Now I have to written here all the observation in ascending order. So now if you observe, count the number of observation. So if you count the number of observation here, it is 7, and which is an odd number. So according to our definition, if n is an odd number, remember there is only one middlemost observation. So the median, value of the median is given by or is n plus 1 by 2th observation. So here n is 7, so 7 plus 1 is 8, 8 upon 2 is 4th observation is the median of the given data. So look at here, count the 4th observation. So you can easily count here, the 4th observation is 90. So 90 is the median of the given data. So let us consider the another example where n is even, number of observations is even. So now I again consider one simplest example. We have to given this data. Now arrange this data in either ascending order. So I write all the observation from smallest to largest here, and then after that we count the number of observations. Here number of observations by counting we get here n equals to 12, which is even. So by mistake here I have to written odd, just be careful about this. So n is 12, which is even, and since it is even, there are two middlemost observation. So median is given by the average of n by 2th observation plus and its next observation. So according to this definition, we put the value of n as 12. So the median is the average of 6th and the 7th observation. Now see here, if you count in the data, the 6th observation is 25, 7th observation is again 25, and that's why its average is 25. So in this case, the median of the given observation or given data is 25. So now suppose our data is expressed in terms of simple frequency distribution. Simple frequency distribution means we have to given the observations. We have to given x1, x2 up to xn, and the corresponding frequencies f1, f2 up to fn. So now in last column I have to calculate here total frequency. Total frequency means we have to add all these numbers f1, f2 up to fn. So this addition of all these numbers gives the total frequency, and which is denoted by capital N. So in case of also here total frequency is N, capital N. So formulas are remains similar as the previous one, because what is the change here? Here the first observation, that is x1 observation, occurs f1 times, f2 observations occur f2 times, and so on. And here total frequency is capital N. In last case, if you observe, each observation occurs only one time, so total frequency is small n. So the formula remains the same here. But in this case, suppose I want to find the median. For that, we first find the less than cumulative frequency. So in first column we have to write all the observation, in second column we have to write all their corresponding frequency, then calculate the less than cumulative frequency. So we know how to calculate the less than cumulative frequency. We add all the frequency from top to bottom. So for first class f1 remains the same. For second class the cumulative frequency is f1 plus f2. For next class f1 plus f2 plus x3, and continue in this way. The last one is the addition of all the frequency, that is capital N. So in this case the median is same as, if n is odd, then n plus 1 upon 2th observation is the median, and actually formula remains the same, because in previous case small n denotes the total number of observation, and here capital N denotes the also again total number of observations. So formula remains the same, only we have to change the symbol small n and capital N. So if n is even, then the median is given by n by 2th observation plus n by 2 plus 1th observation upon 2. That is average of n by 2th and its next observation is the median if n is the even number. So now let us consider the two examples. So question is find the median of the following data. We have to given the observation, we have to given the corresponding frequencies. Now here the first thing is we have to calculate capital N, and so for that we have to calculate the less than cumulative frequency. Actually the question arises in your mind is that why we have to calculate less than cumulative frequency if we can directly calculate capital N. But now see here, it is easy to write the n by 2 or n by 2 plus 1th observation from less than cumulative frequency. So now first thing is we have to write in first column all the observation, in second column we have to write corresponding frequency, and in third column we have to calculate the less than cumulative frequency. We add all the frequency from top to bottom. So first number as it is 8, then in 8 add the corresponding class frequency, that is 20, 8 plus 20 is 28, then 28 plus 35, the frequency of the corresponding class, which is 63, and just continue in this way. So finally we get here 99, which is the total number of frequency or total frequency. So now here what is n? N is 99, and which is an odd number. So if n is odd, we know that the median is nothing but n plus 1 upon 2th observation. So write the formula and put the value. So 99 plus 1 upon 2 is nothing but 100 upon 2, that is 50th observation. And now how to decide which observation is 50th observation or 50 value? I have to return the answer is 130. But just observe the previous table again. See, in previous table we have to calculate the less than cumulative frequency, and using less than cumulative frequency you can easily find which is the 50th observation. See here, the less than cumulative frequency indicates that the first number is 8, so there are 8 observations whose value is equals to 115. Next 20 observations are there whose value is 120. Next there are 35 observations whose value is 130. So we want to find the 50th observation. Now see here, from 29 to 63 all the observations are 130. So obviously the 50th observation is again 130, and that's why we have to consider the 50th observation. First 8 observations are 115, next 20 observations are 120, that is up to 28. Up to 28 the observations are either 115 or 120, but onwards 29 and onwards up to 63 all the observations are 130, and by formula the median is 50th observation, which is 130. Okay, so this is the purpose of less than cumulative frequency. Using this we can easily find the median of the given group or the given series. Now let us consider the another example. Just we consider here, in another example we consider number of observations capital N equals to E1. Then what happened? So we have to given the data as usual as a previous example. In first column we have to write observation, in second column we have to write all the frequencies, and in next column we calculate here less than cumulative frequencies. So the last number is here total frequency, that is capital N, which is 110. So 110 is a even number. So to calculate the median we use the formula median equals to n by 2th observation plus n by 2 plus 1th observation upon 2 if n is a even. So now here n is 110, which is even number. So calculate 1 by 2. So n by 2 is 55 and its next observation is 56. It is sufficient to calculate n by 2, which is 55, and next observation is 56, and take the average of these two value. So which is the median of the given class. So if you observe the again previous table, both observations are 55 as well as the 56. All these observations are 30. Both the observations are 30 here, and so average is 30. Just look at previous table here. So if you observe the less than cumulative frequency, so according to the less than cumulative frequency, the first 10 observations are nothing but the value 10. Next 23 observations are value 25. If you count the observations, or if you observe the observations from 34 to 65, all are 30. 34 to 65. The values of the observations from 34 to 65 are 30, or each observation is 30, and so 55th observation is also 30, 56 its next observation is also 30, and so 30 plus 30 upon 2, that is its average is again a 30. So the middlemost observation is 30 here, and that's why the median equals to 30. Okay, so this is the last type of data. If the frequency distribution is given in terms of classes, so then how to calculate the median of the given class? So now in that case the formula is group frequency distribution, that is we have to given the classes, we have to given the corresponding frequency. So in this case how to calculate the middlemost observation? So for that we will use one formula. The formula is median equals to L plus in bracket capital N by 2 minus cumulative frequency upon F, that is C dot F upon F into H. So we will use this formula to calculate the median if the data is expressed in terms of group frequency distribution. So now here we will see what are the different meanings of all these symbols. Here capital L is the lower boundary of the median class, Okay, we will see how to locate the median class after this one. Then next one is the n. So as usual we know that n is the total number of frequencies or total frequencies. Next is the cumulative frequency. CF denotes the cumulative frequency below, that is, it is the cumulative frequency of the class previous to the median class, cumulative frequency of the previous of the class which is previous to the median class. Next one is the frequency of a median class. F denotes the frequency of the median class. And last one is the h. H is the width of the class. So already we know how to calculate the width of the class. Here we consider the width of the median class. So the question is here, how to find the median class. So we know that median is nothing but the middlemost observation, and to find the median class, first we have to find the cumulative frequency, as usual less than cumulative frequency. So now we consider one example. Actually by taking one example we will clear all these symbols also. And median class is nothing but, to find the median class, first we have to find n by 2. N is the total frequency, and median class is the class where the median falls or n by 2th observation falls. We find first n, then find n by 2, and the class where n by 2th observation falls is called the median class. So it is the class where the number n by 2 is equal or just exceed first times. So let us see how to locate median class and how to find all the variables in the formula. So for that we consider one example. Find the median for the following data. If you observe here, first of all, class intervals are given, number of students, that is frequencies are given, we have to given, and first of all observe here all these classes are continuous. There is no gap between the two classes, and since there is no gap between the two classes, class boundaries are same as the class limits. So now for that, first we have to calculate less than cumulative frequency. So here first column is marks, second column frequencies, and next column is the less than cumulative frequencies. So I have to return first number 8 as it is in the first row. Next number is addition of 8 plus 20, that is addition of first two frequencies. Next number is addition of first three frequencies, that is 8 plus 20 plus 36, which is 64 here, and continue in this way. The last number is 100 here, that is total frequency capital N equals to 100. Now we have to decide the median class. So for that we have to calculate n by 2. So 50 upon 2 is 50, 100 upon 2 is 50, and the 50th observation is the median of the given data. So now we check where this n by 2th, that is 50th observation falls. If you see the less than cumulative frequency from 29 to 64, all the observation falls in the class, or all the observation lies between 20 to 30. So now here we starting with the first column of less than cumulative frequency and check whether where the frequency is greater than or equal n by 2 first time. So now here 8 is less than n by 2. Remember here n is 100, so n by 2 is 50. So 8 is less than 50, 28 is also less than 50. Next 64 is greater n by 2, that is 50. First time this less than cumulative frequency exceeds n by 2. So this class is called a median class. So to find the median class, we first find n by 2. Here n is 100, so n by 2 is 50. So check the class or check the frequency which is just exceed 50, and that is the third class, that is 64 frequency. Less than cumulative frequency is the frequency which is just exceed 50. So corresponding class, that is 20 to 30, is called the median class. So since we get a median class here, so we write all the values of the formula. So first we require the L. L is small l is the lower boundary of the median class. Here median class is 20 to 30, so its lower boundary is 20. Next is we required small f, which is a corresponding frequency, that is frequency of the median class, which is 36 here. And next cumulative frequency, we say here cumulative frequency below. Cumulative frequency below means it is the cumulative frequency of the class which is below the, just below the median class, that is previous to the median class. So the median class is 20 to 30 and the previous class is just previous class is 10 to 20. So corresponding cumulative frequency is 28, that's why CF equals to 20F. And now H is the width of the class, and we know that if the class having equal length, the width is nothing but the difference between the successive lower bounds of successive classes or upper bound of successive classes. So you can take any two classes here. Suppose I consider the first class 0 to 10, next class is 10 to 20. Their lower bounds are 0 and 10 and their difference is 10 here, and that's why the width of the class, each class here is 10, and that's why I have to take here n equals to 10. So width of the median class is also 10, that is 30 minus 20, which is 10. Now this is a formula. Formula to calculate the median is L plus in bracket n by 2 minus CF upon F into H. Now first we have to put L is 20 here, so put the value of 20, then plus n by 2, n is 100, remember the n is total frequency, already we have to calculate it. So 100 upon 2 is 50 minus CF is the cumulative frequency which is 36, so put the number 36 upon F. F is the frequency of the median class which is which is a 36, put the 36 and into height into width which is 10, and just do all this calculation using calculator or manually. So you can easily check the median of these observations or given data is 26.11. Okay. So now our next and the last example is about if the classes are not continuous. So how to find the median? Is procedure remains same or there is something change in our formula or procedure? So now for that we consider one example. So this is our example. We have to given in first row marks 1 to 10, 11 to 20, 21 to 30 and so on. So here we can observe that there is a gap between the two classes, that is classes are not continuous, here these classes are discontinuous. So in this case just remember we have to find to make the classes continuous, so for that we have to find the class boundaries. So first of all you can observe that here all the classes having the equal width, and second thing is if you observe the difference which is also equal, which is the difference of 1. So here difference D is 1 and then we take its half, 1 by 2 is 0.5. So to make the classes continuous, to find the class boundaries, for that we should subtract 0.5 from the lower limit of each class and add 0.5 to the upper limit of each class. So we will get the class boundaries or we will get the continuous classes. So see in the next table we have to write all the marks, so we have to calculate the class boundaries of each class and then write the corresponding frequency as usual, as it is 2, 3, 5, 4 and 2. Next we have to calculate the less than cumulative frequency, and now if you calculate the less than cumulative frequency, you observe here the last number is n, that is 16. So here total number of observations is 16. So to find the median class, now next procedure is similar as our previous problem. So for that, to find the median class, first we have to calculate n by 2. So here total number of observations 16, 16 by 2 is 8. Then find the less than cumulative frequency where or find the cumulative frequency which is just exceed n by 2 or equal to n by 2 first time. So if I observe the first row, first cumulative frequency is 2, which is less than 8. Next frequency is 5, which is again less than 8. Next frequency is 10, which is greater than 8. 8 means n by 2. Remember what is 8? 8 is n by 2 here. So here the third class or the less than cumulative frequency of class 3 is just exceed n by 2, that is 8, and that's why this class is known as the median class. So this is a median class. So we just put the cumulative frequency of its previous class is 5, and for median class the lower bound is 20.5. So now first write the formula for median, calculate all the variables, all the numbers, and then calculating we will get the median of the given. So here observe the median class. The lower bound of the median class is 20.5 because the first, second, third class is the median class. Corresponding frequency of the median class is 5. So F is 5. CF denotes the cumulative frequency of the class which is just previous to the median class. So the cumulative frequency is 5 here, and H is the width of the median class which is 10. So write the formula. Median equals to L plus in bracket n by 2 minus CF divided by F into 100. Now put all these values, just calculate. It is very easy to calculate. So we will get the answer here 36.5. Let's summarize the today's lecture. In this lecture we have studied median, different formulas of the median in various data. If data is in series, if data is grouped or ungrouped frequency distribution. So there are a little bit difference between the formulas. So let us recall the overall lecture first. So median is nothing but first of all it is the positional average, it is the middlemost observation is called the median. So if we have to given the series number of observations only x1, x2, xn, that is each observation occurs only one time. So total number of observations is say small n. Then median is nothing but the middlemost observation. If n is odd, in that case there is only one middlemost observation. So median is n by n plus 1 by 2th observation is the median if n is even. But if n is odd, in that case there are two middlemost observation, and we take the average of these two middlemost observation as a median. So if n is even, in that case the median is given by the formula n by 2 the observation plus its next observation, that is n by 2 plus 1th observation upon 2. So now this is a formula in case of only series. Suppose we have to given the simple frequency distribution, that is we have to given the observations x1, x2, xn, and the corresponding frequencies f1, f2 up to fn. Then in that case we find the total frequency that is small f1 plus f2 up to fn, which is denoted by, this sum is denoted by capital N, and the formula remains as it is. Only in these two formulas we have to replace the small n by the capital N. So we will get the formulas for the median. And last, if the observations are given or the table or group frequency distribution, in that case median is calculated by using this formula. Median equals to L plus n by 2 minus CF upon F into H. Here L is, first we have to find less than cumulative frequency. The last number of the less than cumulative frequency is capital N, that is total frequency. Then to find the median class we should find first n by 2. Then find the class where less than cumulative frequency just equal to n by 2 or just exceed n by 2 first time. So after finding the median class, the small l is the lower boundary of the median class. Small f is the frequency of the median class. Cf is the cumulative frequency of the class which is just previous the median class. And h is the width of the median class. And remember one more thing is, if the classes are not continuous, there is a gap between the two classes. So in that case we should find class boundaries and then apply this formula. So next lecture we will study what are the merits and demerits of the median, because every measure of central tendency has some merit as well as the demerits also. So next lecture we will study the merits and demerits of the median. Also we will study how to find the median by using graphical method, and some basic concept or the definition of mode and the related examples. Thank you.